Okay, welcome back. This is Mr. Hassan's Maths channel, and we're going to answer question number 9 from the January 2024 Pure Mathematics P1 exam from Edexcel International A-level exam. And this question here is about sketching quadratic expression. So it says sketching a quadratic curve. So the curve C1 has equation y equals f of x. We're told three things about the curve: that it's a quadratic expression, it has a maximum turning point at 220, and that it passes through the origin. So we need to sketch a graph first showing the coordinates of any points where this where the curve cuts the coordinate axes. Okay, so we know it's quadratic. When it's a quadratic, it can either have this shape or this shape. All right, it has a maximum turning point at 220. That means it can't be this one, it must be this shape, because it has a maximum turning point. Quadratic only has one turning point. Okay, so that means it's going to be this shape, which is frowny face. The maximum turning point is at 220, and it passes through the origin. Sketch the graph of C1 showing the coordinates of any points where it cuts the coordinate axis. So the information they've given us here is enough for us to make a sketch of the curve, as well as find the equation of the curve, which is actually part B. So if we want to make a sketch of the curve, we can do so with this information. So let's just make it neat. So we're going to have our axes, y-axis and x-axis. Okay, we know that it's a quadratic expression. It passes through the origin, and it has a maximum at 220, which is going to be somewhere in this region over here. So what I'm going to do is I'm just going to draw a curve that passes. I'm going to draw a quadratic that passes through the origin. So I'll just draw this. It doesn't have to be neat or anything too neat. That's fine. In fact, you know what I'm going to do? I'm going to do something else. I'm going to just forget about the axes first. Whoops, I got rid of too much there. Okay, I'm just going to draw a quadratic in the middle of space, which is a frowny face, as neat as possible, without making it go through any points, just so that I can make it neat. This is how I would do it in the exam, to make sure that I don't mess up the shape of the graph. So I'll just draw a quadratic, make it look proper, something like that. So it's not going like this, it's not going back on itself. It's okay, not bad. Okay, so now I know that if I draw my y-axis like this, my x-axis like this, sorry, I know that it passes through the origin. So definitely the y-axis is going to go through this point over here. Okay, so that's the origin. I know that the maximum is at 2 and 20. So that's the maximum. Okay, so I know it had a maximum, so I know it was a frowny face. And I know that this is called a line of symmetry. The line of symmetry passes through the vertex. So this is the line of symmetry passing through this point over here. Therefore, we know that it crosses this, because it's symmetrical. This is going to be, if that's 2 units, that's going to be 2 units, that's going to be 4. Okay, so that's a nice way of drawing the curve. Okay, it's a bit messed up in this section here, so let me just try to fix that a little bit so it looks a bit better. Okay, going to reach its maximum and then down. That's okay, that's fine, no problem. Okay, I could just maybe adjust this a little bit, and that should be fine. Okay, so there is our quadratic. Okay, this is the graph of C1, y equals f of x, which you don't know the equation for right now, but I think that's what you have to find. So there's a sketch of the graph showing the coordinates of the points where it crosses the y-axis. Just to make it clear, this is the point 4, 0, and this is the point 0, 0. Okay, and that's it. Right. Then part B says find an expression for f of x. So we know it's a quadratic, and we know the turning point, and we also know that it passes through the origin, and also 4, 0. So we can in fact answer this in 2 ways, and I'll show you both ways. Okay, we can answer this question. One way would be by using the turning point, the vertex, and the other one is by using what's called the roots. Okay, so there's 2 ways of doing this. Let's say we used the roots method. okay, because we know what the roots are. We know the roots are x equals 0 and x equals 4. Those are the two places where it crosses the x-axis. Okay, where it crosses the x-axis. Should label those better. Okay, so that means if we were solving the equation, okay, we would have had a situation like this. This would have stemmed from x minus 4 equals 0, and this would have stemmed, of course, from x equals 0. So before this, you would have had something like x times x minus 4 equals 0. If you were solving a quadratic equation, you know, you'd have got to this stage, then you say either x equals 0 or x equals 4, right? And there could have been a constant here, which you have to write down. That it was multiplying by this that constant I have to write as a, because I don't know what it is right now. We know for sure it's going to be a negative number because we can see that this is a frowny face. So we have y equals ax squared plus bx plus c. Definitely this number has to be here a negative number. This has to be a negative number, right? So definitely a is going to be a negative number for sure. We know that, right? So we know that y equals ax times x minus 4. That's what this would have been before you made it equal to 0 to find the roots. It would have been of this form. So that would have been the equation of the curve. You'd have said, okay, let's find where it crosses the x-axis by putting y equals 0, and then you'd have divided by a, get rid of the factor, and then you would have then said x equals 0 or x equals 4, and you got your roots. So that's like the origin of the roots. Before that, it might have been something which we have factorized to give us this. Okay, but anyway, now what we can do here is we can try to figure out what a is. We have to know what a is. Now what we do know is we know that this goes to the point 220. This curve satisfies this equation. So do the point x equals 0 and x equals 4, but the problem is if I put x equals 0 in here, the a is multiplied by 0 and it disappears. We can't find what it is. If I put x equals 4 in here and y equals 0, the a again is going to be cancelled out because it will be a times 0. You won't find what it is, but we know that it goes through the point 220. So this point is on the curve, so this point satisfies this equation. So if this point satisfies the equation, we can use this point to find the value of a. So instead of y, I'm going to put 20. Instead of x, I'm going to put 2. So 20 equals a times 2 times 2 minus 4. So I replace the x with 2 and the y with 20, and that will help us to find what a is. So this is going to be 2a times minus 2, so you end up with minus 4, so 20 is equal to minus 4a, therefore a is equal to 20 over minus 4, which is negative 5. As I said, it's going to be negative as we determined, so y is minus 5 times x minus 4. They didn't tell us to write it in any particular form, but I think it's better to write it in the form that ax squared plus bx plus c, so minus 5x squared and plus 20. Plus 20x, sorry, not 20, 20x. Of course, you know, this fits our answer when x is 0, y is 0, and when x is when y is 0, x is going to be 0 and 4. Okay, and so that gives us the answer to this question. So there's our answer. Now I mentioned also we can work it out in another way by using the vertex. Okay, so we know that the vertex is 220, and we know that equations in the form complete to the square are something like this. You have a times x minus p squared plus q. This is the complete to the square form of an equation of a quadratic. So pq stands for the center of the vertex. So we know the vertex is at 220. So we can say y equals a times x minus 2 squared plus 20. That would be a quadratic whose center is 220. Remember, it's the x value that makes this bracket 0 is the x coordinate. Okay, so then 2, when you put 2 in here, that makes it 0. That's right. What's left behind is the y coordinate. Now we need another point on the curve. Now 220 won't help us because 220 will make this bracket 0, which will cause a to disappear when you multiply it by 0. So we can use either of these 2 points. I could use the origin. Why did I put 0,8? That's 0, 0. I just spotted that now. I don't know why I put 0,8. 0, 0. Okay, and 4, 0. Go back to correct that. Now, so we can use either 0, 0 or 8, 0 or 4, 0. Okay, those 2 points are on the line. So what I can do is I can put when y is 0, have a times, and x is 0, minus 2 squared plus 20. So we have 0 equals minus 2 squared, which is 4, so 4a plus 20. So we have 4a equals minus 20, so a equals negative 5. Minus 20 divided by 4. So we can say that y equals minus 5 times x minus 2 squared plus 20. And just to show that even if we use a 0.40, it will get the same answer. We'll have 0 equals a, which we have to find, and you're going to have 4 minus 2 squared plus 20. Again, this is going to give us 4 minus 2 squared, which is 4a plus 20. It gives us exactly the same value of a. So it doesn't matter which of these 2 points we use, these 2 roots, we will still get the answer because both of those 2 points are on the curve. Okay, we can't use 220y in this case because that will make this bracket 0. The a will be multiplied by 0. You won't be able to find what it is. So this is our answer. We can leave it like this because it didn't tell us how to it says find an expression. It didn't say in the form ax squared plus bx plus c, but just to show that they're the same thing, I'm going to expand this just to show it's the same thing. So you have minus 5 times, that's x squared, minus 4x plus 4 when you expand that, plus 20. So you have y equals minus 5x squared plus 20x minus 20, and then outside is plus 20. These two cancel out and we got exactly the same thing. Y equals negative 5x squared plus 20x. And there we have our answer, and we've got to it in 2 different ways. One by using the roots, because we knew both the roots. One by using the vertex, which was 220. Okay. Sometimes you don't have the roots, you only have the vertex and some other random point on the curve, then you have to use this form. Sometimes you don't have the vertex but you have the roots, so you can use this form. Okay, but in this case we have both the roots and the vertex. We can choose which of the 2 forms we want. Either of them would be easier. I think the roots way was easier here. Sometimes this way is easier. So there we have it. That's the answer to question number 9, A and B. Okay, now for part C. So it says the curve C2 has equation y equals x times x squared minus 4. So this is like some sort of cubic curve. The curve C1 and C2 meet at the origin and the points P and Q. Given that the x coordinate of the point P is negative, using algebra and showing all stages of your working, find the coordinates of P. Okay, so this curve is going to, if you think about it, if you factorize this, you have x plus 2 and x minus 2. So it's going to cut the x-axis at 0, as I told us, and x equals minus 2 and x equals plus 2. Okay, which is none of these 2 places are not where the other curve intersects. We want to intersect the x-axis with this curve. Okay, so basically, we want to find the x-coordinate of the point P where this curve and this curve intersect. And as we know, to find the points of intersection between 2 straight lines, 2 curves, all right, whatever they are, you have to use simultaneous equations. So we have the equation of C1, which is y equals negative 5x squared plus 20x, and the equation of C2, which is y equals x times x squared minus 4. So to find where they intersect, you have to substitute one of the equations into the other. So I'm going to replace the y here with x times x squared minus 4, and therefore that will be equal to minus 5x squared plus 20x. Some people say equate the 2 equations. In these cases that also kind of makes sense, it works, but sometimes it doesn't, especially when you don't have y as a subject of one of the formulas, like for example when you have equations of circles or something like that, which comes up in it can even come up in P1 without you knowing it's a circle. So you have to understand that you just replace the y in one equation with what y equals in the other. So that's how we solve simultaneously. So now we can try to solve this by expanding this bracket. So you have x cubed minus 4x equals minus 5x squared plus 20x. Now if we bring everything on one side of this equation to find its solutions, which will tell us where they intersect, we got x cubed on this side. I'm going to add 5x squared to both sides. I've got minus 4x on this side. I'm going to take away 20x from both sides. So I end up with this equation, x cubed plus 5x squared minus 24x equals 0. And as we can see, x is a common factor in both of these, in all of these terms. We take out x, we're left with x squared plus 5x squared, 5x, sorry, plus 5x and minus 24 equals 0. As we can see, one of the solutions to this is x equals 0, as they told us. They intersect at the origin. But the other solutions to this will be given by, when we solve this equation, x squared plus 5x minus 24 equals 0. So we got to factorize this if it does factorize, and that will help us to find the other places where they intersect. So we're finding two numbers that multiply to give us negative 24. So we're going to have x and x. One is going to have a positive in the bracket, the other one will have a negative, because we multiply different signs, you get a negative answer. And we're going to find two numbers multiplied to give you 24. And the difference between them is 5, because they have different signs. So you have 24 times 1, that doesn't work. 12 times 2, that doesn't work. 3 times 8, that works. The difference between them is 5. So we have a positive x, so it's going to be plus 8 and minus 3. So x plus 8 and x minus 3 equals 0. So when you solve this, you have x plus 8 equals 0, or x minus 3 equals 0. So that means x equals negative 8, or x equals 3. Now they asked us to find the x coordinate of the point P, which is negative. Okay, so we're told that the x coordinate of the point P is negative, and we've got to find the coordinates of P. So we've got to choose the negative x value. So we got to choose, so P is when x equals negative 8. That will give us the point P. When point P is, okay, where the x coordinate of that point is negative. So therefore we've got to find the y coordinate. So we can use either of the two equations. We have y equals x squared times, x times x squared minus 4. That was x squared minus 4. We also have y equals minus 5x squared plus 20x. Which will be easier. I think the second equation will be easier to use. You can use either of them because they both intersect at the same point. So when x equals negative 8, we can say that y is equal to negative 8 times negative 8 in bracket squared minus 4. So that's going to be negative 8 times, that's 64, positive 64 minus 4, which is 60. 6 8s are 48, so that's going to be negative 480. So the point P is going to have the coordinates negative 8 and negative 480. And we can check, does that also satisfy the other equation? So we can say that when x equals negative 8, y is equal to minus 5 times negative 8 squared plus 20 times negative 8. That's going to be minus 5 times 64 minus 160. So that's going to be 300, or negative 320 minus 160, which is negative 480, which matches with this. So therefore we know that we're correct. So we can say the coordinates of P are negative 8 and negative 480. Okay, I can see that some people might have made the mistake here of putting 3, or using 3 to find the coordinates of P. That's a different point. That's where they intersect, but a different point, not P. P is where x is negative. Okay, so that concludes this question number 9 from this paper, January 2024. Other questions from this paper can be found in the playlist that will appear at the top of the screen over here. Other questions from this topic, which is to do with, I guess, sketching curves and quadratics, I guess. You can find the playlist for that over here. You can subscribe to the channel by clicking on this link, and the video here will show you how to use my channel to find things that you might want to find efficiently. Thank you for watching and see you soon.